So the area formula is similar to the regular area formula. Area 1/2 equals 1/2 base times height. But before you do, these are some things you need to know how to do in your calculator. Use a calculator to find each trig ratio. So this is like normal. But these are all what kind of angles? They're all over 90, which makes them obtuse. So you can find a trig ratio of obtuse triangles, and you type in tangent of 150. Go ahead and type that in. And then round to the nearest 4 decimal places. What's the first one? Negative 0.5774. Did anybody not get that? I will explain what it means when we get there. I promise. All right, what about sine of 120? So you type in sine 120. Yep, 0.866. You can add the 0 if you would like. And the last cosine of 95. Negative 0.0872. So whenever you see these are like gifts from me to you. They're simple. They're cushion your grade. But also, this is the setup for when we find the area of a triangle, of a non-right triangle. So I'm going to show you the technical formulas, and then I'm going to dumb it down a little bit. Okay? So one of the area formulas is 1/2 BC. What does B and C stand for? B stands for something off this picture.
Angle B.
It's a lowercase. A side B, yeah. All right, and then C represents side C. And then sine of capital A. What does capital A represent? An angle A. So what will happen is, for each of these, if you see this one is side A, side C, and angle B. And the next one, can we make a guess of what it will be? We have BC, angle A, AC, angle B. What do you think the next one would be? AB, and then angle C, so sine of C. So here is what the formula is in a dumbed down version. It's 1/2 times the side you're given, and sine of the angle you're given. So if you would like to write this down, I would. If you want to memorize the 3 different formulas, you can do that as well. The 1/2 is the same as the area formula for a regular triangle, times the side, times sine of an angle. Here's our example. We're going to find the area.
Seniors, this is just a reminder.
So area equals 1/2, whatever the side they give you, times the side they give you, times sine of the angle they give you. So all we do is plug and chug. What is the side, the measurement of the side they gave us? Sure, 17. What's the other one? 19. And then sine of the angle, which is 135. Guess what we do with this, y'all? We type it all on your calculator. Straight up type it. The whole thing. It tells us to round to the nearest tenth. So 1/2, 17, or times 17, times 19, times sine of 135. 114.2. And this is units squared, technically, because we just found the area of this triangle. All right, so in the next example, we're going to talk about the law of sines. In this one, I want you to write next to it that you're going to be making proportions. I want you to write, make a proportion. So this is the one we make a proportion. Heaven help those who are learning from this video because it was interrupted 4 times. Just throwing it out there to those who are listening.
Did you pause it?
Yeah, I paused it. They don't need to listen. Here we go. You use this for different things that you're given. But before you write anything down, I'm just showing you what you'll be doing. You'll be using a sine sine of an angle over the side across from it. So every angle corresponds with the side across from it, just as a recap. Angle A is across from side A. Angle B is across from side B. Angle C is across from side C. Are we all okay with this? When we talk about a lowercase letter that is a side, when we talk about an uppercase letter that is an angle. So here's what you're going to end up doing. You're going to write a proportion. Does anybody remember what a proportion looks like? A fraction equal to a fraction. So it could look as simple as a proportion, not here, but if it said x over 5 equals, I'm just going to make something up, 10 over 27. Okay? This is a proportion because it is one fraction equal to another fraction. Okay? So what we're going to do is set up a proportion. What would happen is you would write a proportion like this to solve for a missing piece. You would either be given two sides and an angle, or two angles and a side, something to that extent. And then you would solve for the missing piece. This could involve any of the sides. But you don't set up three proportions. You only set up two proportions. I promise it will make sense when we get there. I promise. So in this one, the angle is on top and the sides are on the bottom. In the next set of proportions, you could also flip it. The side is on the top. So in the next one, the side would be on the top and the side be on the top. You're going to create a proportion using these. It doesn't make sense right now because you don't see what we're going to use it for. But it will, I promise. What decides between which of these you use, and you want to write this down, you want what's missing on the top. So whatever's missing, you want it in the top fraction. It just makes your life a little bit easier. You wouldn't be wrong if you didn't, but it's one less step, and I promise it will make sense when we all apply it. Okay? So that's it. We're going to do our example. Okay? Going to do our example. My life. Here we go. So solve the triangle. We have a triangle here. What does solve the triangle mean to us? To find everything, right? Find the missing angles. So we're eventually going to find the measure of angle C. We're eventually going to find the measure of angle B. We're eventually going to find the side length of C. Okay? So we're going to set up a proportion to solve for one of these things. Okay? So what you want to look for, you want to look for a known pair. That's what we call it, a known pair. And I will explain what that means to you. A known pair is an angle and a side. So meaning, if we knew angle A, we also know side A. If we knew angle B, we also knew side B. If we knew angle C, we also know side C. So a known pair is the angle and the side that we know. So do you see if we have a known pair up here? What letter do we have? A. So we have the angle A. We also have side A. So we're going to use our proportion. We can't find C first because here's what we're going to end up doing. Okay, we're going to end up either using A over sine of A, or we're going to use sine of A over side A. And what will happen is we need one missing piece, not two missing pieces. Do we know anything about side C or angle C? No. So we can't find anything about that one yet. What we do know is we don't know angle B, but do we know side B? We do know that one. So we could use the known pair we have, which I highlighted in green, and find the angle we don't know and use the side we do know. Okay? So we're going to set up a proportion. If we're going to use a proportion, I told you want the missing piece in the top. Are we looking, if we're using B, are we looking for a side or an angle? If we're looking for an angle. We're looking for angle B. So we're going to use this bottom. We're going to use the bottom one. Sine of angle A over A. Where'd it go? Sine of A. And we're going to set it equal to sine of B over lowercase b. And we're going to plug in a second. Okay, so we are using our known pair, which is in green. And we're going to plug in the side we know from sine of B. All right, so what is the angle of A?
115.
115, I agree. So we plugged in for angle A. What is side A? 20. We're going to set it equal to, do we know angle B?
No.
No. So we're going to write angle B. Do we know side B? Yes, 11. From here you just solve. So the hard part is setting it up, but if you notice my angles are on the top, both of my sides are on the bottom, and we're going to solve like we would solve a regular proportion. What do we want to solve for in the end? We want to get angle B by itself. Right now it's attached to sine of B, so we need to get sine of B all by itself. What is happening to sine of B? It's being divided by 11. What is the opposite of dividing by 11? Multiplying. So in your calculator, you're going to end up multiplying all of the left side together. So 11 times sine of 115 over 20. You want to make it look exactly like it is on the screen. Yep, just like that. And leave it. You should get a pretty crazy decimal.
0.4.
Yep, don't do anything with it yet. I'm going to write it down. Should we round in the middle of a problem? Think about it. No. If you round the middle of the problem and you do something with it, because we haven't solved for B, we only solved for sine of B. If sine of B is 0.4, what? 498,469, blah, 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 blah. Don't erase it. We need to find angle B. But what is on the same side as angle B right now? Sine. How do we get rid of sine? The inverse. So we're going to do the inverse of the answer. So don't type anything in if you don't know how to answer this. So you're going to hit shift sine, and then you're going to hit answer, A-N-S. That uses the previous answer you just had. So you're going to hit shift sine, and then answer, and then hit enter. Are we all okay with using ANS? Round to the nearest tenth. What do we get?
29.9.
29.9. So what did we just find? Angle B is 29.9. We are going to use that in a second. Angle B is 29.9. So right away, do you think we could find something else without even doing any new information? How can we find angle C?
Add the 2 and then divide it over.
You just use a lot of words, and I think I knew what you were saying, but you did not. So you add them together, because you have now 2 angles out of 3 angles. You know the 3 angles in a triangle add up to what number? 180. What is 115 plus 29.9? 144.9. Okay, so 180 minus 44.9. What is it, 35.1? 35.1. So we just found angle C to be 35.1. Because of us finding that, we can now find side C. Because if angle C is 35.1, we now know the angle, and we're missing the side, so we can set up a proportion. What you will want to do is use the same setup we had before, as in sine of angle A over A, all of this, except for we aren't going to use B's, we're going to use C's. Okay? Are we missing a side or an angle? A side. We're missing a side, so the sides need to be on top. So we're going to use our known pair, A over sine of A, and we're looking for side C, so C over sine of C. So we're going to do the same process we just did. All right, so what is side A? 20 over sine of angle A, which is still 135. All right, and then equals, oh gosh, cancel. Equals side C, which is, we don't know, so we call it C, over sine, and what is angle C? What do we find it to be? 35.1. All right, so now what is happening to angle or to side C? It's being divided. So what's the opposite of dividing? Multiplying. So we're going to multiply both sides by sine of 35.1. Both sides. I know I ran out of room on that side. And then we'll figure out what side C is. So you'll type it in exactly like you see on the screen. Sine of 35.1 times 20 over sine of 135. What do we get rounded to the nearest tenth?
16.3.
16.3?
Wait, so how come it's 135? Yeah.
Oh, that's not right. Sorry. It's 115. Sorry, I thought this was a 35, not a 115. All right, so sine of 35.1 times 20 over sine of 115. 12.3. Oh, no.
That was
That was a different one.
12.7.
12.7. And we circle this. So law of sines is a proportion that you set up using the known pair. So the number one thing is finding the known pair first. So the side and the angle that you know. All right, we're going to do another example. Just wanted to give people time. Solve the triangle. Round answers to the nearest tenth. You'll like these because we need to find an angle. We need to find the measure of angle. What is it? Angle A. But we already have 2 angles out of 3 angles. So what do we do with those? Add them and then subtract from 180. So what is 107 plus 25? 132. You're good. Which would be 48. So the measure of angle A is 48. All right, so from here, we need to find our known pair. So the known pair is the side and the angle you know. So what side and angle do we know here?
B.
Angle B, yeah, B. All right, what side would we like to solve for first? Sure, let's solve for C, which means we're going to end up using 107. So are we missing an angle or a side? A side, so the sides need to go on top. It just makes your life a little bit easier. Don't overthink it. If you don't do that, it just is more algebra for you to do later. So the sides need to be on top. So we'll do 15 over sine of what angle? I think it's 20. That's a 25. Okay, so we just did side B over sine of B. Now we're trying to find side C over sine of, what's the angle? 107. All right, so we need to solve for angle C. All right, so what's happening to C? It's being divided by sine of 107, so what do we do? Multiply by sine of 107. All right, so you type that directly in your calculator. Sine of 107 times 15 over sine of 25. Round to the nearest tenth. What do we get? 33.9. Do we all agree?
Yes.
Okay, 33.9. So I'm going to write it off to the side here. C equals 33.9. All right, and we're actually going to do the same thing for side, I think. What are we finding? Side A. So we use the same known pair. So we still use what I have in green. We're not going to change. This is all what they gave us, so we're going to use it again. 15 over sine of 25. This time, we want to find side A, so we're going to use 48. So side A over sine 48. I'm sorry, those two words sound very, very similar. All right, so how do we solve for side A?
Multiply.
I'm going to multiply. We'll get rounded to the nearest tenth. 26.4. So A equals 26.4. So if you look, this makes sense. What was my biggest side?
107.
Or my biggest angle? And then my biggest side was 33.9. It was across from my biggest angle. My smallest side was 15, and it's across from my smallest angle. That will still happen because it's still a triangle. Okay? We're going to do, I think, one more with the law of sines, then we learn the law of cosines. All right, so a surveyor makes the measurements shown to determine the length of a bridge to build across a small lake from the north picnic area to the south picnic area. Find the length of the bridge. All right, so in this one, we are finding from the north to the south. Which of these go from the north to the south? Which side?
Side C.
Side C. So we're actually just solving for side C, because all we're doing is figuring out how far it is to build a bridge from the north to the south. All right, so do we have a known pair?
No.
Oh, but we do. We got 150. Don't you have two angles in a triangle? How do we find the third? Add, subtract from 180. So 71 and 60 make 131. From 180, what's the missing angle? 49. So we do have a known pair. All right, so we're going to use that piece. We're going to use 150 and 49. We're trying to find C. So what angle are we going to use? We want to find side C. So what angle corresponds with side C? 60. So we're going to set up a proportion using these four things. We're missing a side, so sides are going to go on the top and angles on the bottom. So I'm going to start with what I do know. I know 49 over sine of, nope,
I thought 150.
it's 150 over sine of 49. So my side is on top, my angle is on the bottom. All right, and then I'm going to find my missing piece. Yes, sir?
Is it always going to, are we always going to use sine?
The law of sines is used when you have a known pair. So you're about to learn the law of cosines, which is a different way to solve for different parts of a non-right triangle. But you can use these. Do you see how it says angle, side, angle? That means you know an angle, a side, and an angle. The last example said angle, angle, side. So that was how you would use sine, law of sines, for angle, angle, side. We're not going to go extremely in depth into this, so I don't think I will have you decide which one to use. I think I would just tell you which one to use. But normally, you would have to decide on your own. But you use the law of sines, which more people are comfortable with, when you have a known pair, a side and an angle across from each other. You won't have that in the law of cosines. All right, so then we have 150 over sine of 49. What's my next fraction going to look like? C over sine of 60. All right, and C is being divided by sine of 60, so I'm going to multiply. Sorry, I ran out of room. I paused.
172.
Did we all get that? 172. Rounded to the nearest, we'll still do the tenth. What do we get? 0.1. 0.1, and it doesn't give us a measurement. Meters? I saw you write meters, I just couldn't read it. Oh, I see, it's an M. All right, so law of sines, you use a proportion. Law of cosines is just a formula. Law of cosines you'll use for a side angle side or side side side. If you see that on your page, I would underline it or highlight it. These are the two times you would use law of cosines. For side angle side and side side side. Side angle side, if you remember, I called this like a ice cream cone. Because you would know a side, you'd know a side, and you would know an angle. I called it an ice cream cone because I just envisioned having ice cream in the top. What do you know for side, side, side? All sides. All right, so the reason being, in side angle side, you don't have a known pair. In side, 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 you don't have a known pair. A known pair, you have a side and an angle mentioned. But in side, 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 all you know are sides. That makes sense. So that's why they created this. This is based off of the Pythagorean theorem. There is a pattern to this. There are 3 different ways or 3 different formulas, but they're all the same pattern. The first one is a squared. Again, I don't know what that is. A squared equals b squared plus c squared, which is the Pythagorean theorem, minus 2bc cosine of angle A. So if you notice, these two match, and then B and C, B and C. You're going to see that for each and every one of these. I can't dumb it down anymore. If this one is what it is. I can't tell you a dumbed down version. So I would write these 3 down if you haven't already started. All right, so the next one, if it starts with b squared, I'll give you a second. So the next one is b squared equals, what do you think these 2 letters are going to be? A squared and c squared minus 2ac cosine of angle B. So again, it's the same pattern. These 2 match as well as these match. And the same thing with c squared. Bless you. This one has a little bit more of algebra to it. And I'll explain that when we get there. This is just another way to look at it. We don't have to look at it that way. So this is a side angle side case. Okay? So you might be asking, how do we know which one to use? So you will use it based on if you're whatever side you're finding or whatever angle you're finding. Okay, that will decide which one you're going to use. In this one, what side does it look like we're going to find?
B.
We're going to find B. So we're going to use b squared. B squared equals, and then a squared plus c squared minus 2ac cosine of angle B. All right, so here I'll label it for you or label it with you. What is side A? 11. What is side C? 14. And then angle B, 34. It's the only angle we know. So we're going to plug in all of those things. We don't know b squared. A squared is 11. C squared is 14. Minus 2 times A, which is 11. C, which is 14. Cosine angle B, which is 34. It is a lot, but that's why you're still using your scientific calculators. Type in everything to the right. And don't clear it. Yes, sir.
Can we use like the Pythagorean theorem to find B? Or?
Is this a right triangle?
Oh, that's the only time we can do it.
Yep. All right, so don't clear it. What do we get? 61 point. Okay, so I'm just gonna say 6.5. So 6. for blah, 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 blah. So how do I end up solving for b squared? What do I need to do next? Take the square root. So here's what you're going to do. You're going to hit square root, and then you're going to say answer. ANS again, because that will be the exact value. So the square root of answer.
7.852.
So round to nearest tenth still. So 7.9. 7.9. All right, so we haven't found everything. We just found one piece. We need to find one more, and then we're finished. So we found B to be 7.9. We need to find the angles. From here, we use law of sines again. We don't keep using law of cosines. Because, do I have a known pair now? I do. I have 7.9 and 34. So I'm going to use law of sines with the b's here. Which angle? I remember this part. You have to find the largest angle first. So which one would be the larger of the two angles? We're going to find C first. So we're going to find C and use side C. So at this point, we are using law of cosines. Are we missing a side or an angle? An angle. So the angles need to go in the top because we are missing an angle. So we're going to use our known. So that would be sine of B over lowercase b. And then we're finding sine of C over lowercase c. All right, so what's my angle B? 34, yeah. And then side B we found is 7.9. Equals, we don't know sine of angle C. Over, what is side C? 14. So from here we solve. How do I get sine of C by itself? Nope. Times 14. You definitely don't want to flip this one. That's why we put what's missing on the top, so we don't have to flip anything. All right, so type it in our calculators. Don't clear it. 0.999. Okay, so how do we get rid of yada yada? How do we get rid of sine? The same way we've been doing it. The shift, the inverse. So do shift sine, and then of the last answer. So you don't have to type it in again. 82.3. So from here, there is no more laws. You just use the very foundational rule. If we have two angles and a triangle, how do we find the third? Add them and subtract from 180. So this one's 82.3. All right, so go ahead and add 34 and 82.3. What do we get? 60 what? Not 60. 116.3, and you're saying subtract from 180, we get 63.7. So that means angle A is 63.7. You'll be all right. Yep, this is the last one we're doing. All right, so which case is this? Side, side, side. Okay, so this is when we especially use law of cosines. All right, we need to find an angle. Here's why we need to find the biggest angle first. So what is the biggest angle going to be? B. So we are going to set up our formula. B squared equals A squared plus C squared minus 2AC cosine of B. This is where your algebra will come into play. You have to use algebra or it's not going to work. You have to do this in the correct order. What is side B? 27 squared. All right, and side A? 12 squared. Side C? It is 20. Minus 2 times side A, which we said was 12, times 20. Cosine of B. So pause before you type anything in. Okay? can I, when I find out what 12 squared is, we all know 12 squared and 20 squared, that's fine. But when I find out what this is, can I subtract this from 12 squared and 20 squared? I can't. Do you see how it's attached to cosine? What is it doing to cosine? Multiplying. So this is like a unit, this whole piece, from -2 all the way to cosine of b. It's a unit. So you cannot add this to these two. So when we do this, you have to be very meticulous. Make sure you pay attention to details. What is 27 squared? Louder.
729.
729. And then 144 plus 400 minus, what is that, 480? No. Is it? 48, no, 720? No, y'all tell me. 480. Sorry, he was making me doubt. And then we don't know what cosine of b is. So here is now our goal. We're trying to get b by itself. Do we all agree? We're trying to find angle b. In order to find angle b, we need to get cosine of b by itself. In order to get cosine b by itself, we have to get this whole piece by itself. So we need to move these two numbers to the other side. Okay, this is just algebra, because this is all being multiplied, and 144 and 400 are being added. All right, so what is 144 plus 400? 544. Again, you cannot subtract that. Okay, but we are going to move 544 onto the other side. We can move that by subtracting that. Minus 544. What do we get? Equals negative 480 cosine of b. So we're almost there. We need to get b by itself, but before that we need to get cosine of b by itself. So what is this negative 480 doing to cosine of b? Multiplying. What is the opposite of multiplying? Dividing. So we are going to divide it by negative 480. I know I am running out of room. We are about to do that, so yes, keep that in mind. Keep it in your calculator. What do we get as a decimal? .3854, yada yada. Keep it in your calculator. How do we get angle B by itself? The inverse. So you'll type in your calculator cosine to -1 of your last answer. What do we get for angle B rounded to the nearest tenth? 120?
112.7.
112.7. All right, after this, do we have a known side? When we have a known side, what do we use? The first one, law of sines. We are not done, so I don't know why you're... So we're going to use that. What angle would we like to solve for? Sure, let's find angle A. So we don't know sine of A over its side, which is 12. We set it equal to the pair we do know, sine of 27 over 112.7. Oh, nope. Sine of an angle. Come on, Mrs. Marshall. Sorry. I'm just trying to hurry up for y'all. Alright, so what do I do to get sine of A by itself? Multiply by 12. So what does sine of A equal? Did you do a different one? .4100, yada yada yada. How do we get A by itself? Shift button of your last answer. What do we get for angle A? 24.2. So now we have angle A. Measure of angle A is 24.2. The measure of angle B is 112.7. How do we find the measure of angle C? Add them and subtract 180. Give me the answer super quick. 43.1. 0.1.